All right, so I'm going to be going over the Unit 10, Lesson 7 assignment today over dilations, the fourth and final transformation discussed in this unit. A dilation is the only transformation out of the four that does not preserve congruence. It does not keep your figures the same size and shape because, by definition, a dilation changes size. In order to change size, we need to know the scale factor at which we are dilating, and scale factor will always be the number that you multiply the pre-image, the original figure by, to get the image, the new figure. So let's get started. So we have quadrilateral EFGH here, and we are dilating it by a scale factor of 3/2. And the origin is the center of dilation, and this is going to create quadrilateral E prime, F prime, G prime, H prime. So here's the graph of our starting quadrilateral, our pre-image. And question 1 has us complete this table with our vertices for both figures as well as our algebraic rule that we will be using to get the new image's coordinates. So pre-image is our EFGH quadrilateral. Image is named E prime, F prime, G prime, H prime. So underneath the first column, let's write down our 4 given points that are already plotted for us, E, F, G, and H. E is at -4, -2. F is at -4, 6. G is at 2, 2. And H is at 4, -2. Okay, so in order to get our new points, we need to understand the algebraic rule. And for a dilation, it's pretty simple. We just take our starting ordered pair and we multiply both the x and the y coordinate by the given scale factor. So both x and y are going to be multiplied by 3/2. That's the scale factor given in the description, and that will give us our new points. So -4 gets multiplied by 3/2, and -2 gets multiplied by 3/2. As -4 and -2 were our starting ordered pair for point E. When we multiply this out, we will get -6, -3 for point E prime. All right, same process for F. So x coordinate is -4 multiplied by our scale factor. Y coordinate is 6 multiplied by our scale factor. So F prime will be at -6, 9. All right, point G, 2 times 3/2 and 2 times 3/2 again, because both the x and y coordinates were both 2, giving us a G prime point at 3, 3. Last but not least, H, 4 times 3/2 and -2 times 3/2. Gives us H prime at 6, -3. So that is how we perform a dilation algebraically to go from our pre-image points to our image points. And then number 2 has us just plot these 4 image points and label on the same graph. All right, so point E prime is at -6, 3. Make sure we are labeling our vertices. F prime at -6, 9. G prime is at 3, 3. and H prime at 6, negative 3. And then, of course, connect to get our quadrilateral shape. And we should notice, of course, it is a larger shape than the pre-image, but still the same shape. Okay, so that's number 2. And then number 3 says, confirm that the new image is similar to the pre-image by drawing projection lines. And what a projection line is you're just connecting the corresponding points. So we're connecting E with E prime, F with F prime, etc. And what this allows us to see is if we truly dilated it correctly, because these projection lines should all intersect at the same location, which will be the center of dilation. In the original description, we are told the origin is the center of dilation. So ideally, when I connect E prime with E, F prime with F, G prime with G, and H prime with H, you'll see how those 4 projection lines do all intersect with each other, and they intersect at the origin, verifying that the origin is the center around which we dilated the shape, and also verifying that we did this dilation correctly. All right, next problem. This time we are given both the image and the pre-image, and we are given some side lengths as well on the pre-image AB and AC, and we're going to answer some questions based on this graph. So number 4 is asking what general statements can be made about these 2 shapes. And we are told that triangle ABC is indeed dilated, so we know that a dilation is occurring. So there are 2 main characteristics of dilations that we want to remember. Number 1, or part A. A dilation, although it does not keep the shapes congruent, it does keep them similar. So that's our first general statement or characteristic we can make about the 2 shapes, which are triangles. And the second characteristic is kind of building off of that. So what does it mean to be similar? Well, the corresponding angles, so A with A prime, B with B prime, C with C prime, are going to be congruent. Those don't change size or degree measure. But the corresponding sides, so AB to A prime, B prime, AC to A prime, C prime, etc., those obviously aren't congruent. Those do change sizes, but they're going to increase or decrease at a constant rate, making them proportional. So all of the sides are going to be twice the size of the original, or half the size of the original, etc. So those are our 2 main general statements about shapes that are dilated. All right, so now we're just going to write down the points for A, B, C, and A prime, B prime, C prime. So I am going to just quickly write down the vertex names and then go back up and find the coordinates. So A is at -9, 3. B is at 9, 9. And C is at 9, -9. All right, A prime is at -3, 1. B prime is at 3, 3. And C prime is at 3, -3. So those points were all given because they were already graphed for us. So now we're going to calculate the scale factor. How do we get from triangle ABC to A prime, B prime, C prime? There are a couple different ways you can calculate scale factor, but it's asking us to compare the length of side BC with the length of side B prime, C prime. So we're going to go up, and what's nice about these two sides is that they are completely vertical, so we can just literally count the boxes and that will tell us the length of those sides. So if we count all the boxes from B to C, we should get 18. And if we count the boxes from B prime to C prime, we should get 6. All right, so BC is 18. B prime, C prime is 6. And it wants us to just write this as a reduced ratio from pre-image to image. So pre-image would be our BC, 18. Image would be B prime, C prime of 6. I'm just going to write this in a typical ratio format. And that can be reduced to a 3-to-1 ratio. So the original side length is 3 times the new side length. Now, when we are calculating scale factor, remember, even though the problem we just did told us to go from pre-image to image, scale factor will always be old over new, new over old, or image over pre-image. So be careful when we are truly calculating this. So same thing, except now our image, I'm going to move this down a little bit. Our image length was 6. Our pre-image length was 18. So that creates a scale factor of 1/3. So just the reverse of the ratio we have from above. So now we are going to confirm that this scale factor works with the points. So if 1/3 is truly the scale factor, then we should be able to take the original points, multiply the x and y coordinates by 1/3, and get our new points. So just what we did in the table in the first problem. So A was at -9, 3. We apply the rule. So -9 times 1/3, 3 times 1/3, and we will indeed get the coordinates of A prime, -3, 1. For B, we started at 9, 9, apply the rule. So 9 times 1/3 and 9 times 1/3 to get B prime at 3, 3. Remember, multiplying by 1/3 is just dividing by 3. And then C was at 9, -9. So apply the rule, 9 times 1/3, -9 times 1/3 to get C prime at 3, -3. And our rule was just what I wrote above. So we go from XY as our pre-image coordinates to 1/3 times X and 1/3 times Y as our image coordinates. All right, now number 9, we are going to compare the lengths of the triangles. We already know that BC was 18. We already counted that. Now, if we go up to AB and CA, you'll notice how they are already labeled with the side lengths, 18.5 18.9 and 21.6. So let's just copy those into our table. AB is 18.9 and AC is 21.6. So actually the process is similar. We just take the side length, multiply it by the scale factor, and we will get the new side length. So same process. So A prime B prime will be a third of the size, so 6.3. We already know that B prime C prime will become 6. We use that above. And then CA becoming 1/3 of the size will become 7.2. Okay, and then last, we're going to compare the angles. So the key here is remembering that statement we made above, where when we're dilating, your angles don't change size. So A and A prime are going to be the same size. B and B prime, the same size. C and C prime, the same size. So we are told what angle A is and what angle B prime is. So if we know that B prime is 60, then angle B must have been 60 degrees because it's going to stay congruent with its corresponding angle, which is B prime. We can skip over C for the time being because we don't know anything about C prime, but we do know for A prime, since angle A was given as 45 degrees, angle A prime must also be 45 degrees. So this one we know because it's congruent with angle A. So now we have C and C prime. But what we should use here is the knowledge that we have a triangle. And all three angles of any triangle will always add up to 180. So in our original triangle ABC, we know that angle A is 45 and angle B is 60. So if we start with 180 and we take off our 45-degree angle for A and our 60-degree angle for B, we will be left with what C has to be, which is 75 degrees. And this is just our triangle angle sum property that we're using here. Okay, and then now that we know C prime has to be the same, 75 degrees. So we need to make sure we understand that angle measures do indeed stay the same size. Okay, now we have two standardized practice questions and we'll be done. So number 11, we have pentagon KLMNO is graphed on a coordinate plane and we're given its 5 vertices. And we are dilating this by a scale factor of W with the origin as the center. Which ordered pair represents the coordinates of vertex N? It should be N prime, I believe, because we already know N, right? So N started at 5, -4, and we know our scale factor is W. And when we have the starting coordinate, we just multiply by our scale factor to get our new coordinate. So M prime, we would start with 5 and -4 and then just multiply by the given scale factor, W, to get the new coordinates. And that matches option C. Okay, and then number 12. So we have quadrilateral RSTU. So this is our pre-image, and we're dilating it at the center using the rule 4/3 X, comma 4/3 Y to create triangle R prime, S prime, T prime, U prime. So what we should notice here is based on the rule, 4/3 has to be our scale factor. And we have learned earlier in this unit what scale factor can do when it makes your shape larger, smaller, or stay the same. So we should know or recognize that 4/3, we're always going to compare our scale factor to 1. 4/3 is greater than 1. You can calculate it, you'll get 1.3 repeating, or you know it's an improper fraction, right? The numerator is larger than the denominator, so this is going to be larger than 1. And what we have to remember is that whenever we have a scale factor larger than 1, our shape is going to get larger. Okay, so RSTU is going to become larger, making R prime, S prime, T prime, U prime larger than the original. So which of these statements matches that? So A is correct in that R prime, S prime, T prime, U prime will be larger than the original, but not because the scale factor is less than 1, because it's not. And a scale factor less than 1 would not make something larger. B doesn't work because it's stating that the new quadrilateral will be smaller, and we know that's not true. C doesn't make sense because, again, it says our new quadrilateral will be smaller. So that leaves us with D. Hopefully this one works out. So our new quadrilateral will be larger. Yes, that is correct. And why? Because the scale factor is larger than 1, which is also correct. So D is the true statement for this transformation, for this dilation. Okay, and that's it for this lesson 7 on dilations. I hope this helps you understand dilations a little bit more, how to use scale factor, understanding what stays the same between the two shapes, aka the angles, and what changes, so the side lengths, and how to find scale factor. You'll still need to submit this assignment to Schools PLP for grading. I can't just assume that you watched this video, so make sure you get that submitted ideally sometime soon.